Hey everybody, we are looking at another exercise from chapter 1 section 7 and we are working in the rational inequality section. I really like this example because this is one of the first ones where we have two distinct denominators happening, not like common denominators already or a random denominator and the other one is basically a 1. So this is going to be fun. So we're going to start off just like all the other cases where we're going to get 0 on one side. And then I'm going to add over this 4 over x, right? Greater than 0. And I'm going to extend my fraction bar there as well. Okay, so I brought everything over. I just left myself a little bit of room. Then over here, I'm going to multiply on top and bottom by x. And over here, I'll multiply on, top and bottom by 2x, take away 1. Boom. Okay. So now that I have a common denominator, essentially, I'm just going to clean it all up. I want you to remember the phrase I'm about to say to you. Don't distribute denominator. Leave the denominator factored, okay? Leave the denominator factored. You're going to expand and clean up, combine the numerator, but don't distribute the denominator. So I'm going to leave the denominator as x times 2x minus 1. Keep in mind that the x is really like an x minus 0 to the first power. Don't forget about that. Okay, on top, you're going to have, what are we going to have up there? You'll have 3x, I'm just going to do the work here, plus 8x minus 4, right? So what is that? That's 11x minus 4. And it's still set to be greater than 0. So this right here is the important step that we are concerned with and we're going to focus on most. So we're going to do the same thing we've done every other time. We're going to get our numbers, our critical values that we get by doing two different things. And those two things are, we're going to set our numerator equal to 0, so it's technically like x intercepts. So x intercept and equal to 0. So we will have 11x minus 4 equals 0, 11, x is 4, so x is 4 over 11. Bam. Now, don't forget, that was first power, odd, opposite. Right over here, right? So that one, odd, up. Okay. And then the other, this is going to be the first time we have this going on, but we're going to set the denominator equal to 0, and that's going to find us our restricted values. So we're going to, or vertical asymptotes, either way. So our restricted values we get by setting denominator not equal to 0. So we will have essentially that x can't equal 0. That one's done. And then we have 2x take away 1 can't be 0. So 2x can't equal 1. So x can't equal 1/2. And then these all came from first powers as well. So another odd, opposite, and odd, opposite situation. Now this one's also interesting, this whole example, because the test number that we have been using of 0 is no longer allowed to be used because 0, if you look right here, it's one of our restrictions, right? So I can't use 0 as my test number. When you can't use 0 as your test number, I would suggest, let me see here, we have 0, 1/2, and 4 over 11. 4 over 11 is smaller than 1/2. So 0, 4 over 11, that's an x-intercept. It's not going to be included in my answer because it's not or equal to 0, but it's not a restricted value. And then over here, 1/2, that's another, okay. So if I can't test 0 as a value, what I would rather do then is I'm going to test like a big number, you know? Maybe you just want to test 1 in this case, not that bad. So depending on the parentheses and everything that's going on, maybe I test like 100. Maybe I test, because if I test 100, I mean, the top's going to be positive, the bottom's going to be positive, so it's going to be positive. But if you test 1, 11 times 1, 11 minus 4 is going to be 7. And then on bottom, you'll have 1 times 2 times 1 is 2 minus 1, 1. Okay, so we get 7. What did I say? 7? Yeah, we'll get 7, which is positive. So in either case, over here to the right of 1/2, you will get positive, and they're all odd opposites. So negative, positive, and negative. It does not always alternate, okay? If the problem had a squared on one of the parentheses, it's a game changer, okay? It's not always going to alternate. It just happens to do that quite a bit. Now, what do we want? Greater than or equal to 0, or not, no equal, but greater than 0. So I'm looking at this little region here and this little region right there. So, ladies and gentlemen, what is the final answer? Well, I'm glad you asked. All right, we are going to have parentheses 0, comma, 4/11, parenthesis, union, parenthesis. Ah, the 1/2 got a little squishy. No, don't do that. I hate when I'm at the very bottom of the screen and it does like weird stuff. Comma, infinity. There you have it. Okay, that's the answer. That's the 1/2 over there. That's the answer. I just wanted to be able to zoom out and kind of get it at least from this step, right? Let's at least get it from there. Okay, so that is everything. If you feel like you're getting the hang of this, great. Let's try some of the harder ones in the little bottom part over there on the page. Or if you want to request an example, you could do that. And maybe go back, revisit those quadratic inequalities, make sure you're doing those correctly. Make sure you remember how to do a compound inequality. Make sure you know how to do all the linear types of inequalities, because maybe you have a little do now quiz tomorrow. We shall see. All right, but that's it for now. Questions, comments, concerns, thumbs ups and thumbs downs. Make it happen. Adios.